The moon, the Earth's only natural satellite. It is the largest of the celestial bodies that illuminate our night sky. It's the only place outside of Earth that a human has stepped on. The moon's gravitational pull causes tidal movements on Earth. These movements might have been the catalyst for the transition of life forms from the sea to land. Moreover, these companion forces prevent the Earth from spinning around its axis, which gives some stability to its climate. But there's a very valid question. Why doesn't the moon fall to Earth? In the 17th century, the famous English scientist Isaac Newton wondered why objects fall to the ground and not the moon. This unusual question is dedicated to one of the greatest discoveries in the history of science, that which, if you disobey this English genius, to understand how he answered this revolutionary question, let's imagine Newton took a ball and threw it hard to safety. So it makes sense that it would travel some distance before it falls to the ground. The stronger the throw, the longer the distance it travels. And if Newton could throw the ball hard enough, assuming no air resistance, the ball would remain orbiting the Earth, and it will never fall. This force, enough to throw an object, was later named the escape velocity from gravity, which is estimated at 11.2 kilometers per second, meaning any object, like satellites, if pushed with this speed, escapes the gravitational pull, and it keeps orbiting the Earth. Newton came to a profound conclusion that the moon is actually falling constantly, just like a ball. But its fall is not vertical like a ball's fall. And the reason is its great speed, 3,700 kilometers per hour. The moon is drawn towards the Earth by the same force that dropped the ball, but at the same time, it moves forward very quickly, compensating for that to civilization. Since the Earth is spherical, it remains in perpetual freefall without ever reaching the ground. And this orbit, as we see it today, is but a result of this descent. This conclusion set Newton on the path to establishing the principles of gravity. He then developed revolutionary equations describing the behavior of the latter. Check its validity experimentally, and we use it to this day. Thanks to it, humans could fly and reach the moon. But what if the moon suddenly accelerated and began to advance towards the Earth? The moon's underlying plan to destroy the Earth by colliding with it will collapse upon reaching the Roche limit. The moon itself would tear apart and never reach the Earth's surface. And perhaps this seems impressive and reassuring. And by the way, for those wondering what the Roche limit is, I'm a home mechanic in Gonya. It's the point where gravity keeps the moon or history together, and it's weaker than the tidal forces trying to tear it apart. In other words, the moon cannot approach our planet a distance greater than 18,381 kilometers. Before it exploded, the tidal forces will tear it apart. All footprints and flags we left behind will scatter. A debris ring breathtakingly suspended above Earth's equator. And the ring, which is 3,700 kilometers in diameter, it would make Earth the second planet in the solar system after Saturn to boast a ring of beauty around it. However, the difference is that our orbit won't last long, for the wreckage of our previous satellite will rain down on Earth. It would be like hundreds of thousands of asteroids falling on our Earth. This is the process that will erase entire cities. And when the moon begins its journey towards the Earth, its tidal effect on us will increase. But when it reaches Roche's limit, this will cause a rise in waves reaching up to 7,600 meters, or 30,000 feet. Our world will be destroyed by tsunami waves that sweep our regions 10 times a day. Of course, daring surfers will find great joy in it. But on the other side, this might be a solution for global warming. As the moon gets closer, the Earth's rotation rate will speed up. Our days will become brighter and brighter, and the global temperature will decrease. And global climate change didn't worry anyone after that. But in reality, the moon never gets closer. It's drifting away day by day, escaping in its orbit around Earth every year. A distance of 3.8 centimeters. The difference in the rotation speed of the Earth and the moon is the main cause for the moon moving away from it, where the Earth completes a rotation around itself in just 24 hours. But the moon needs 27.3 days to complete a single rotation on its axis. This significant disparity creates several results, pushing the moon away by 1.5 inches each year. In addition, another outcome is a slight slowdown in Earth's rotation speed. In 100 years, the day will be longer by approximately 2 milliseconds than it is now. And of course, the question that arises here, what if the moon moved far enough away to escape Earth's gravity? Will Earth actually miss it? Or will it simply pass unnoticed? Find out the answer in this video. Humans have developed a close relationship with the moon over the ages. The impact of this versatile silver satellite is clear on our diverse civilization. Whether it's utilizing its phases in the calendar, or its role in the tides, and how that relates to global navigation. But let's imagine our Earth without a moon orbiting it. Naturally, our nights would be darker, and the term 14 moon would no longer be widespread among human languages. Our moon is constantly moving and drifts from its path by an estimated 1.5 inches away from the Earth annually. This process results in a slowdown of Earth's rotation. So what if one night we looked up at the sky and didn't see the moon? Today the moon simply celebrated. So will we miss its presence? The brightness of the full moon is on average 4,000 times greater than that of Venus in the night sky. So, in the absence of the moon, all our nights will be as dark as those before the birth of a new moon. This sight will cause great astonishment to night sky observers. By the following morning, you'll realize how crucial the moon is for life on Earth. To begin understanding the interplay between the Earth, Sun, and Moon, the Moon has the greatest effect on the Earth's tides. Tidal movements will decrease by 75%. This could endanger the lives of many organisms, like cancer, mollusks, and marine snails, the ones living in the tidal areas, and that will disrupt the food system of many animals that rely on it for sustenance. This process will threaten the ecological system in all coastal areas. Over several decades, we'll begin to see a significant decline in human populations at sea and on land. One of the greatest breeding events on the planet occurs in the Great Barrier Reef in November every year. On the night following the night of the full moon, coral colonies along the city's reef release. This led to an area larger than the state of New Mexico, covered in millions of eggs and jellyfish. Minutes apart from each other, scientists are certain that the full moon plays a role in this timing, but the way this is done remains a mystery. Inland, creatures such as these red crabs use the lunar signal to signal the start of the breeding process. Instead of spending most of their lives in the mountains, millions of these adult crabs migrate towards the beach and beyond,
Only during the last quarter of the moon phases, females release their eggs into the sea. Now, the moon might not have much influence on human reproduction, but without it, one of the things we equally care about will change. It's the climate. Tidal mixing and the resulting currents blend cold, polar water with warm tropical water. This contributes to the balance of thermal energy and climatic stability around the world. Without the moon, tidal fluctuations would be almost impossible. As for the temperature differences between the coldest and hottest areas on Earth, it would reach limits that threaten life on this planet. But all that we've mentioned pales in comparison with the greatest change the coming millennium will witness. Currently, the Earth's axis is tilted at an angle of 23.5 degrees. This deviation is largely due to the moon's gravity. If the moon disappeared, the Earth's axis would swing in a range between 10 and 45 degrees. Some experts predict that Jupiter could slow Earth's axial tilt under control, but just a 10-degree shift in the axis could destabilize the weather and the seasons. In the past, Earth's axial tilt changed by 1 or 2 degrees, which scientists agree was a cause behind the ice ages, and it's hard to know who will produce a deviation of 10 or 45 degrees. However, it is likely not suitable for most forms of life on Earth. Having the moon is not only crucial for life on Earth today. Experts believe it may have played a role in the origin of life over 3.5 billion years ago. It turns out the moon is not just a beacon in the night sky. Its presence is central to the delicate balance that makes life possible